So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over a quick topic test with a collection of some GCSE exam style questions on properties of polygons at higher level. Now a copy of the questions for you to have an attempt at before watching through this video is available for you to download by clicking on the link in the description, which I strongly recommend you do to see how much understanding you have on this topic. So let's get started on this properties of polygons test. So looking at question 1, it says that here is an isosceles triangle, the base is extended, circle the equation that is true. Now for this particular question, I would say, and this might not be the only way of approaching this question, but I would say that this angle here, and I'd label it as x. So to work out x, I can work it out as either doing 180 minus a plus b, or I could work out x by doing 180 minus c. And so from this, what we can see is that I'm going to be taking away these two things to give me that angle of x. So therefore, a plus b must equal c, which is our second option. Moving on to question 2a, it says work out the exterior angle of a hexagon. Now to work out the exterior angle, it's 360 divided by how many sides there are in the shape. So for this, because it's a hexagon, it's going to have 6 sides, so it's going to be 360 divided by 6, which gives me an answer of 60. It then says write down the interior angle. So there's a couple of ways in which you could do this. You should know that the interior angle plus the exterior angle both add up to 180. So if I can do 180 minus 60. So it's going to give me 120. Alternately, you could just use the formula to work out the interior angle, which is using this formula where n is the number of sides, in which then it would be 180 multiplied by 4 divided by 2, which also gives me the answer of 120. Then for question 3, it says which of the following properties is true for a kite. Now with these questions, I would always recommend that you draw to the best of your ability the shape. So here we've got a kite, and then just go through each of the options. So has it got a rotational symmetry of order 2? No, it hasn't. Are opposite angles equal? Well, these two are equal, but this one is not equal to that one. Do the diagonals bisect each other? And no, because this horizontal one doesn't bisect the vertical line exactly halfway. And does it have one line of symmetry? Yes, it does. So that there is our correct answer. Moving on to question 4, it says here are 6 quadrilaterals, and the question is asking us to write down the names of the quadrilaterals that have no lines of symmetry. So for this one, just by looking at it, you should be able to say that it's going to be the parallelogram, and the trapezium, and you can write those in any order, the 1 mark. If you miss any of those shapes out, you would lose a mark. Moving on to question 4b, it says 3 of the quadrilaterals are square, rectangle and rhombus, and the question's asking us to give a reason why a rectangle could be the odd one out. There's a couple of reasons you could say. You could say something along the lines of, I'll just use a different colour. So you could say that not all sides are equal length. So in a square and a rhombus, all the sides are equal. And you can also say that the diagonals do not cross at a right angle. All 90 degrees all say that they're perpendicular. So something along those lines would be fine. It then says give a reason why the rhombus could be the odd one out. And again, a couple of answers you could give here, something along the lines of that not all interior angles are 90 degrees. Or you could say something along the lines of not all angles are equal. And again, any of those two answers, but certainly when it only asks you for, and it's only worth 1 mark, I wouldn't give a series of answers. I would just be confident in one and just go for that one. Because obviously if one of them is incorrect, or you want to give 2 answers, it's a shady place to go. I would just stick with however many marks, that's how many reasons you want to say. Moving on to 4c, it says tick one property of these 3 quadrilaterals that they have in common. So you've got a square, a rectangle and a rhombus. And again, I would always recommend to students that they draw the shapes out just to get a vague idea, just to help you know which one you are ticking. And for this, you want to be able to tick that the diagonals bisect each other exactly halfway. And again, just proof of that. So here you can see that they bisect, here they bisect, and here they bisect each other. Moving on to question 5, it says that a regular pentagon and a regular octagon have sides of same length. The pentagon is drawn inside the octagon as shown. Work out the size of angle X. So for this, angle X is basically going to be equal the interior angle of the octagon minus the interior angle of the pentagon. And as we previously mentioned, the interior angle of a polygon is 180 n minus 2, all divided by 2, where n is the number of sides. So if we look at the interior angle of the octagon, that's going to be 180 times the number of sides is 8, so 8 minus 2, all divided by 8, and then we can work that out, and that's going to equal 135 degrees. We then work out the interior angle of the pentagon. That's going to be 180 times 5 minus 2, all divided by 5. That's going to give me an answer of 108. And then just take away 135 minus 108, and that's going to leave me an answer of 27. Moving on to question 6, it says, which of the following formulas does not work out the interior angle of n-sided polygons? So remembering that this formula, as we've already mentioned, is 180 multiplied by n minus 2, all divided by n. So what you want to see is when you simplify each of these expressions, which of them will give you this formula here. Now, in terms of, I don't know what's happening with the formatting of this, but that should be a minus. So let's just go through the process and see which one does not give me that one. So if I was to, well, let's start with this first one. So here I'm going to have 360. Now, because the denominator is the same, I can write that as 1 minus n over 2. I could take the 2 and divide by 2 to 360, so that gives me 180, 1 minus n. And as you can see straight away, that's not going to give me the same formula. So that one there is definitely, that's not going to work. For this next one here, does this work? Well, that is the same as that one, so that one is going to be absolutely fine. For the third one, let's have a look. We've got 360, and then if I try and get a common denominator, well, my common denominator here is going to be 2n. So I need to multiply this by n, and that then becomes 2n, and then multiply the second fraction by 2. That then becomes 2n, and then joining those up, I get 360 multiplied by n minus 2, all divided by 2n. I've put that extra bracket there, which then gives me 360 n minus 2 over 2n, and that 360 cancel that to give me 180, which gives me the same formula as this, so that one there is fine. With this one, well, if I expanded the bracket, so if I had 180 n minus 2, I would end up over n, I would end up with 180 n minus 360 all over n. And I'll have 180 n over n minus 360 over n. That cancels with that, which leaves me with this, so that one there is fine. So the only one that's doesn't give me that interior angle formula is going to be the first option. Moving on to question 7, it says that a regular polygon has 2 sides extended. The angles between the extended sides is 100 degrees. How many sides does the polygon have? And you must show your working. So for this, let's have a look at what we've got. Well, if that's going to, this angle here, these two sides are going to be equal. So we can then do 180 minus 100 divided by 2, and that's going to equal 40 degrees. So this angle here is going to be 40, and this is going to be 40 as well. And working out the interior angle, well, that's going to be, if the exterior angle is 40, well, there's a couple of ways in which I could do this. I could do 360 divided by n equals 40. So 360 divided by 40 equals n, and that gives me, so n equals 9. So that's one way of doing it. Another way, you can then use the formula to work out which sides it's going to give you it to, but I would say the exterior angle way is going to be a whole lot easier, so the answer there is going to be 9. Then moving on to the last question, it says that a regular decagon and a regular pentagon have sides the same length. They are joined as shown, and it says prove that ABC is a straight line. To help you, part of the diagram is reproduced below. Your working may be shown on the diagram. Now, when it comes to proof questions, you always want to start by saying what's going to be true to prove that what they're asking you is true. So, for example, what I'm going to write here is if ABC is a straight line, then angle B or DBC must be the exterior angle of the, and that shape there is the octagon. Just double check, of the decagon. Double checked. So therefore, it must equal 36 degrees. So that's the proof that I'm going to be using, because obviously if this is a straight line, then this angle here is going to be the exterior angle of that angle there. So this is going to be my general proof that I'm going to use to see if that's true. So if we start with this, well, we can start by saying that the interior angle of the decagon is going to be 180 times 10 minus 2 divided by 2, which gives me an answer, divided by 10. And that gives me an answer of 144. So this angle here is 144. We can then work out what the interior angle of the pentagon, and just double check it is a pentagon, and yes it is, of the pentagon, using the same formula. So it's 180 times 5 minus 2 divided by 5, and that gives me an answer of 108. So this angle here is 108. Now, going back to our diagram, we can then say that this angle here is also going to be 144, because obviously, therefore, it is another interior angle of the decagon. Now, because the sides are equal, this is basically going to be an isosceles triangle. So the triangle of BDC equals isosceles as BD equals DC. Now we can then work out what this angle here is by doing 180 minus 144 minus 108, and that should give me an answer. Let me just quickly work that out on my calculator. So 180, oh actually not 180, it should be 360. Where have I got 360 minus 144 minus 108, and that gives me an answer of 108 degrees. So this angle here is 108. So then I can then work out, as it's an isosceles triangle, I can then work out what these angles here are. So here, angle, let me just write this down. So we've got angle BDC equals 108 degrees. So therefore, angle DBC or angle DCB is going to equal 180 minus 108 divided by 2, which equals 36. So therefore, A, B, C lie on a straight line. And there we go, because I've proved that in order for it to be on a straight line, that angle then, this angle here, needs to be 36 degrees, and I've then gone on to prove that it does equal 36 degrees. And that concludes this polygon test.